2, Charge Tape Revisited. So an introduction to this lab, the purpose of this lab basically is to build on the results from Lab 1 and divide the tapes into smaller segments where each tape is a point charge, then find the net charge on the tape. Now, to do some assumptions, we can assume that each section of the tape is a singular point charge, we can ignore air resistance, and that both tapes have the same amount of point charge, and the system would be tape A and the surroundings would be tape B in the earth. Some results from this lab is that the charge clear tape has a net positive charge, and the charge of this tape is 9.33 times 10 to the negative 10 coulombs, and the tape is deficient of 1.53 times 10 to the negative 8 electrons. Now, some key concepts of this lab. First, we're going to be using Newton's second law, which basically says that the net force on an object is the change in momentum over the change in time, which is summarized to the force equals mass times acceleration. Then we'll also be using the gravity near the surface of the Earth, which basically states that the force of gravity equals mass times the force of gravity on an object equals mass times gravity. And then we'll also be going into the electric force, which is Coulomb's law, Newton's third law that states that every action has an equal and opposite reaction, and then the electric field equation. So the procedure is basically the same procedure as Lab 1. It's the same experimental process. The difference is that when calculating the charges of the tapes, we would be breaking the tapes up into segments and looking at them as individual point charges based on those segments, as opposed to in Lab 1 looking at each tape as an individual point charge. So when looking at the experimental data, again, it's the same as Lab 1. And now going into the GlobeScript code and the computational model. Now, a bit of a discussion for after the lab for Lab 2. You can see that the value of the charge was found that gives the electric force that is equal in magnitude to the force of gravity. Now, this means that the net force in the entire system is 0, causing the U-tape to float as the electric force is cancelled out by the gravitational force. And this concept is justified by Newton's third law, which is the law of reciprocity, which basically states that every action has an equal and opposite reaction, so that a force on an action will have an equal and opposite force on that same object. Now, based on the number of deficient electrons, we can conclude that the charge of the tapes are positive based on observations. Now, we must include the possible sources of error for this lab, and that includes the possible inaccurate measurements of the tape length and width, inaccurate measurements of the separation distance, being that the held tape could possibly be not parallel to the suspended U-tape, and that there is an error due to rounding calculations. Now, to end the discussion, we can ask the question, what if you had modeled each of your tapes as a single port charge like in the previous lab? And we can look at our charges that were calculated in the previous lab versus in Lab 2, and you can see that they're extremely similar. So we're now looking at what does this necessarily mean, considering that the two charges are particularly similar. And that means that the estimates from the two charges differ because the estimated from this lab, which used the line charge model, is more accurate because it mimics the shape of the tape. And that means that by using the line charge model, you're breaking up the tape into individual port charges based on each segment of the tape, which gets a better read of the net force that's spanning on the tape, as opposed to taking the entire length of the tape and compressing it into one point charge, which doesn't accurately represent the size and shape of the tape. Thank you.